But other than going over the basic parts, most of this PowerPoint is how do we make urine? What's in urine? What shouldn't be in urine? How is urine formed inside the kidneys? Now, there are 3 main processes in the making of urine. The first one, the glomerular filtration, is talked about in the intro video. So if you haven't watched the intro video, watch it this weekend. Part 2 is tubular reabsorption, which we're going to start today. I don't know how far we'll get in it. But it's the fact that we reabsorb about 99% of what gets filtered. And so when urine is made, I didn't even bring all my colors over, blood goes in the glomerulus, blood comes out, but filtration happens in here. And we make about 180 liters of what we call filtrate every single day. That's how much we filter. Do we urinate that much? No, that'd be 92-liter bottles. You do not urinate that every single day. But we make 180 liters of filtrate every day. 99% of that gets reabsorbed, which means we make, on average, about 1.5 liters of urine a day. And again, that varies by how much you drink. But the reabsorption is, well, what are we all reabsorbing out? Yes, a lot of that is water. And I'm like, but where is all that reabsorption taking place? So we're going to talk about reabsorption. We're also going to talk about secretion. There are things in the body that we can secrete into these tubes to get rid of out of the body. There are things that we have in our body, there are toxic things we have in our body that we can get rid of because we can secrete them into these tubes and then urinate them out of the body. So we're going to start talking today with tubular reabsorption. And then next Tuesday, we'll finish the tubular reabsorption wherever we end up and get through the rest of the PowerPoint, the secretion. But I'm going to skip ahead to our tubular reabsorption. So when I say most of the tubular contents, 99% of all of that filtrate, it's not called urine after it's done being filtered, it's just called filtrate. 99% of that urine filtrate gets reabsorbed back. Now, it's a selective transepithelial process, which means there are different channels to reabsorb different things. That's where the selective comes in. But just about all organic nutrients are reabsorbed. When I talk about organics, what does organic mean? I heard it. Carbon-based things. These are amino acids. These are your proteins. Various types of sugars like glucose. Just about all of that is reabsorbed back in the body, which is why we shouldn't have proteins and why we shouldn't have sugar in your urine. We reabsorb that. And water and ions, lots of water. Water and ions are reabsorbed mostly hormonally, and we're going to talk about some of those hormones today that are controlling the reabsorption. And again, I'm not artistic. This is my nephron. Mostly, and I'm like, and I drew the distal convoluted tubule bigger for a reason, because I'm going to draw more stuff up there on it. And I'm like, but we're going to talk about what's happening at the proximal convoluted tubule for reabsorption and what's happening at the distal convoluted tubule for reabsorption. But we're reabsorbing 99% of what goes in here so that it stays in our body and does not get urinated out. Now, to reabsorb it, some of it's active processes, which mean need ATP, and some of it are passive processes. I forgot my clicker. Now, starting with the very first thing that we reabsorb, and it is an active process, meaning it requires ATP, is sodium. So I'm going to talk, reabsorbing water, nutrients, and ions. Well, sodium, is the most abundant cation that we have in our filtrate. So all of the blood that we filter, there is lots of sodium that's going to be in here. Cation means it's positively charged. Now, we are going to actively pump out sodium. In the proximal convoluted tubule. Lots of reabsorption happens in the proximal convoluted tubule. We're going to take ATP and we're going to pump sodium out. Now, this is going to create an electrical gradient. We just moved positive ions out. which means what's going to want to follow? If this is really positive over here, what's going to want to follow it? What's the opposite of positive? Negative. And I'm like, so there's an electrical gradient, because you'll leave a lot of negative here and all those negatives, like, I don't want to be all by you guys. I like positive. And so anions are going to follow. And so we pump out sodium, we pump out positively charged cations, and then because of that, because you left a lot of these negative things in here, it will allow negative anions, like chloride, to leave. Now, other organic nutrients, like glucose and amino acids, are reabsorbed by what's known as secondary active transport. Again, it usually comes with the sodium, that when we are using ATP to pump sodium out, we usually use a lot of protein carriers that will pump something else with it. Well, let's take that energy, and if we're pumping sodium out, let's tag along some amino acid with it. So it's secondary active transport. It's still requiring ATP, that's AA for amino acid. But when we pump out sodium, we pump out other things with it. It's like, well, if we're going to put all this energy to pump something out, let's see what else we can go, pump out there. Now, things that we are going to reabsorb. And I'm like, we are going to reabsorb glucose, amino acids, ions, and vitamins. We're going to try to keep that in our body. Because anytime we reabsorb things out of here, that means it stays in our body. We want to be able to hold on to those and keep those. So the big thing, sodium, ATP. We pump sodium out. Now, if sodium leaves, guess what wants to follow it? I was going to say it's on the top of there. Top line. What always follows? Water will. It's kind of my thing, salt sucks. Wherever sodium or salt goes, so does water. It's why you get thirsty when you eat salty foods. If we are pumping sodium out, that will leave your filtrate with additional water in it, and water wants to go where there's not as much water, and water will leave with sodium. So by actively pumping out sodium, water is also going to get reabsorbed. Now, there are channels. This is my channel. In your proximal convoluted tubule called aquaporins. Aqua means water, porin means it's a channel, or it means it's a pore, a hole. And I'm like, but it's one of these water carriers. And so water is going to want to leave. So by pumping sodium actively out, we are also reabsorbing water. And again, you don't urinate out 180 liters a day. Now, we have lots of aquaporins in the proximal convoluted tubule. I drew one, but there are lots of them in the proximal convoluted tubule. The fact that we're just always trying to reabsorb that water. The fact that we're just always trying to reabsorb water by pumping sodium out is called obligatory water reabsorption. It's just we're obliged to absorb water. Now, we'll talk a little bit more about the next part, but occasionally we can insert some aquaporins over here. They don't normally hang out there, but we can put some aquaporins over here if we want to. It's usually controlled by a hormone, which I'll talk more about coming up, called the antidiuretic hormone. So the antidiuretic hormone is going to insert additional aquaporins. Again, the job of an aquaporin is to reabsorb additional water. And if you reabsorb water, it means it's not going to end up in your urine. You're holding on to the water. Now, other things. I know I should have made this bigger too. We're going to actively pump out sodium. Other things will leave with it, like anions. Water will leave. But if we are pumping out, and I'm like various types of ions already, whatever is left is going to be more concentrated. Well, then we have another gradient, and so when you pump stuff out, whatever's left becomes concentrated, and nothing likes to be in a highly concentrated area. So whatever's still left in here is like, well, we don't want to be the last ones here. so there's lots of us left over, they will also leave. And so your solute concentration that's left in here, after you pumped out other ions, after you pumped out tons and tons of water, and pumping out because we're reabsorbing it, whatever's left here is really concentrated. So because we pumped all this other stuff out, this becomes concentrated and it will leave as well. Other solutes will leave because they don't want to be concentrated. They want to go where there's less of them. And so fat-soluble substances, some ions, are going to get reabsorbed back in the body just because they became highly concentrated in that proximal convoluted tubule. We pumped everything out, they become concentrated, they don't like to be concentrated, they get reabsorbed back in the body. Now, this can become an issue because there are some lipid-soluble drugs, fat-soluble substances, and some environmental pollutants that we never get rid of. They always get reabsorbed back in the body. And I'm like, which becomes an issue. It means we have toxins in the body that you never urinate out. They constantly just keep getting reabsorbed and back into the body, and they stay in the body forever. Now, at some point, there's only so many carriers. There's only so many channels in the proximal convoluted tubule. What can happen is if you have too much of some type of solute, too much ion in here, if all of your carriers are full, because they're already pumping something across, if they're already full, you're going to hit what's known as the transport maximum. Now, because I want to talk about one particular one. It's the glucose. I'm just going to pick another color. Glucose is reabsorbed. You should not have sugar in your urine. And we have channels that their job is to pump glucose out. There's two of them. Sloppy. But if my two are full, they're already pumping glucose out, but there's still glucose here. If those carriers are already busy, they can't pump out any more glucose. And that's when glucose or sugar ends up in the urine, is when there is so much of something in that filtrate that there is not enough carriers to reabsorb it back in the body. This is what happens with diabetics. Their blood sugar is so high that there is so much glucose in here that there is not enough carriers to reabsorb that sugar back into the bloodstream, and that glucose will eventually make its way out and end up in the urine. It's one of the biggest symptoms of diabetics is that their urine smells sweet. Now, my note, and I'm like, if glucose is left in here, which is a solute, what will want to follow it? Because it's a solute. What follows salt? Water. Well, glucose is also a solute, and water will follow it as well. It's why diabetics, one, they have sugar in their urine. It's a big key. But two, they urinate often. Is because that sugar, that solute, holds on to the water. And so I'm like, if there is solute in here, additional water is going to be in there. They urinate a lot, and there is glucose in their urine. Because there's so much glucose. All of those carrier channels are full. And so when all your carriers are saturated, when they're all full, and you can't reabsorb anything else, it ends up in your urine. Now, the proximal convoluted tubule is the site of most reabsorption, hence my lots of messiness going on. So all of your nutrients like glucose and amino acids should be reabsorbed here. If they're not, there's an issue like diabetes. About 65% of your sodium in your water is reabsorbed here. Lots and lots of different types of ions, and most of your uric acid and about half of the urea, which we find urea later on too. The Nephron Loop that hangs down, it does have a descending limb. I did not draw mine to scale. It does have a descending limb, and there are aquaporins in the descending limb, and so we can have water leaving in the descending limb. Usually that happens up in the top part. If you notice, is the nephron loop the same width the whole way through? No, there are some skinny parts and there are some thick parts. There are different channels found in there. It's not all the same. And so there's lots of aquaporins still in that thick region. And so water can leave because there's lots of aquaporins, but it doesn't have a lot of channels for other things to leave. And I'm like, when we go into the ascending loop, again, you've got a thin area and you've got a thick area. The thin segment has lots of sodium channels for reabsorbing sodium, and the thick segment has additional carriers for moving things together. We can move sodium and potassium together as well as chloride ions. And I'm like, they're called symporters. We're going to move them all together. We also have something known as a sodium hydrogen antiporter. Anti means against, which means this is we can pump sodium out and then we can pump hydrogen in. They go in opposite directions. And so there are different parts, there are different things going on, different carriers found in different places on the nephron loop. Now, any guess why would we want to get rid of or secrete hydrogen ions? What do hydrogen ions control? It's found in hydrochloric something. It's the acid. And I'm like, hydrogen ions mean acidic. What does your blood pH have to be in? What range? Is that a big range? No. And I'm like, again, other than the fact your respiratory system does help control your blood pH because of our breathing changes and regulating those bicarbonate ions, your urinary system also helps controlling your blood pH. If your blood is becoming too acidic, it has too many hydrogen ions, it can get rid of some of them here. Now, the distal convoluted tubule and the collecting duct, of course I move a table and now it's in my way over here. Pretty much any reabsorption here is all hormonally controlled. There are 4 hormones. You have to know the hormones. Just like you had to know the cells. It was asked several times on your test today. You have to know the hormones. Now, the first hormone is called the antidiuretic hormone, and it controls water movement. I already briefly talked about it. Aldosterone controls sodium movement, and anywhere sodium goes, water will follow. And then we have the atrial natriuretic peptide, which also controls sodium movement, but in a different way. And then we have the parathyroid hormone, which controls calcium uptake. Now, I've got a slide on each of these, and I'm going to draw up here too. But this are all controlling distal convoluted tubule and the collecting duct. Now, your antidiuretic hormone, it's also just nicknamed the anti-P hormone. And if you have something that's called anti-P, are you going to urinate? No, which means we want to reabsorb more water. If you reabsorb more water, you're not going to have as much urine being formed. That's the whole basic of it. It's called antidiuretic. It's stopping the urination. Now, the posterior pituitary gland, because coming up in lab is the endocrine, and I'm like, and the posterior pituitary gland controls antidiuretic, preview and endocrine stuff. It causes cells in the collecting duct to insert aquaporins, so that more of that water gets reabsorbed. And so these aquaporins are not normally found in your collecting ducts. It's at some point, something has to trigger your posterior pituitary gland to start secreting this antidiuretic hormone, and the hormone inserts these additional channels in here. More water gets reabsorbed. Now, reasons why this would happen. If you're working out and sweating, if you were losing a lot of water, do you want to make a lot of urine? Probably not. We want to try to conserve as much water as possible because you're sweating out a lot of water. We don't want that water to end up in your urine. If you had massive fluid loss, if you had massive blood loss, that's a lot of fluid loss out of the body. Well, we don't want to take what fluid there is and urinate out anything additional. Those are some things that would trigger your antidiuretic hormone to kick in and start reabsorbing additional water. So it's called the anti-P hormone for a reason. Now, the aldosterone hormone also targets the collecting duct and the distal convoluted tubule, and it promotes the making of an additional channel. It makes a channel called the sodium and potassium channel, and it uses an enzyme called ATP or the ATPases to move these things. Well, if it inserts it, I want a different color. We're going to insert more channels in our distal convoluted tubule and in the collecting duct too. We're going to reabsorb sodium, and anywhere sodium goes, what follows? Water will follow. This is so that we are trying to keep sodium in the body. We're also trying to keep additional water in the body. Reasons why we do this. If you have too much water in the body, in your bloodstream, and I'm like, anytime you have additional blood volume, it does increase blood pressure. If we can get rid of, or if we can absorb sodium and absorb additional water, your blood volume, I was going to say, I guess, goes up. Yep. And I'm like, it goes up. If you keep the water in your blood, you have additional blood volume. And the more blood volume, the more blood pressure. It's not a huge difference, but blood volume, more blood pressure. If all of a sudden your blood pressure is decreasing for whatever reason, your body will trigger reabsorbing more sodium to reabsorb more water to increase your blood pressure back up. Now, my own little note, when something positive leaves, we try to offset that by putting something positive back in. And so when aldosterone, just writing aldosterone up here. This is aldosterone at work. And I want another color. Sorry, I didn't realize it was right at 4. When something positive leaves, something positive should go in. And I'm like, and this particular positive that's go in is potassium, which also helps regulate potassium levels in the body as well. I'm like, we'll start pick up right there on Tuesday. Again, if you haven't already taken a look at the intro video, take a look at it. I think that's the only main thing. I know the endocrine system quiz has now opened, but you've got 2 weeks to do it.